Here in the Ottawa COVID geodatabase, COVID feature dataset, I have ONS. I'll just bring that in. ONS contains the Ottawa Neighborhood Study neighborhoods. And if I have a look at the attribute table here, it contains the names of the neighborhoods, the IDs of the neighborhoods, ONS ID, name. And then at the end here, I have the cumulative rates per 100,000 people of COVID-19 up until the end of October, and the number of cases in each neighborhood up until the end of October from the beginning. So the cumulative case count, as well as the population estimates for 2019 for each of these things, each of the neighborhoods. Now, unfortunately, I want to do some analysis with census data that isn't at this neighborhood level scale. So I'm just going to bring in the census tract data here, CT 2016. So the first thing we can see here is that we have different geographies. So if I just zoom in a little bit, let's say to this location here, and I go to the make the layer a little bit transparent. So I'll go to the appearance tab, swipe that over a bit. You can see that the boundaries don't line up at all. Lighter colored lines are the census tracts because I made them partially transparent. And the dark lines are the neighborhoods. And you can see right away there's a geographic mismatch between these. They just don't match each other. So for example, with this neighborhood right here, Billings Bridge, Alta Vista. If I just select that to show you. And then I turn on the CTs. And I might make those a little bit less transparent so you can see the differences. So that's one neighborhood, and you can see there's 1, 2, 3 different census tracts that intersect that neighborhood. And if I look at the census tract data, I don't have anything about COVID in here because it's not reported at the census tract level. So it's only reported at the ward level, which is course, and the Ottawa Neighborhood Study neighborhood level, but not at the census level, which I want because I want to analyze it to see if there's any relationships between the prevalence of COVID, the rates of COVID in the census tracts, and things like the median income, the visible proportion of visible minorities, etc. With population, people with university diploma. So I might hypothesize that given what I've heard within the media, that there should be potentially higher rates of COVID in census tracts with higher proportions of visible minorities and Aboriginal people, and perhaps less in areas where there's a lot of university education, more potentially in immigrant versus non-immigrant populations. So to look at these type of relationships, I need to get these COVID counts from the neighborhood level to the census tract level right here. And I'm just going to start by clearing anything that I have selected. And I'll zoom back out. Now I could do a basic area interpolation, but because I'm going from slightly larger spatial units, which are the neighborhoods, as we saw, one neighborhood had 3 tracts in it. There's 111 neighborhoods and about 213 census tracts. So I'm going to a slightly, different zonation, but also perhaps a different scale of things. And I want to do this as accurately as possible. So I'm not going to go with a basic area interpolation. I'm going to use an ancillary data set here called the zoning data. So I'll bring that in. This zoning data tells us where people actually live in space. And what I want to do is assign the ONS data to the zoning level. So for example, if I just look up in this polygon over here in the corner, I'll click on that and see how many cases we've had in there. Might be a very cumulative rate. So in total, there's been 17 cases in that neighborhood since the beginning of the pandemic. And I want to assign that those, I should say those 17 cases amongst or to the residential regions where people actually live, because that's where the 17 cases are happening, or are residing, I should say. This doesn't tell us, of course, where they caught COVID, but it shows us where they reside. And by knowing where they reside, we can check and look at things like the socioeconomic status of the group, or the ecological level here, at the polygon level, the census tract level. We can do analysis such as, looking at the relationship between socioeconomic status and COVID rates. So first I want to bring the ONS data down to a spatially focused layer, which is this mask layer here called the zoning. In the zoning, open up the attribute table for zoning. Zoning is a single giant polygon with multiple parts. So the first thing I'm going to do is intersect the zoning or ancillary layer, the binary mask, with the ONS data to just assign values to the binary mask. So first I'll do some imports here. I'll say from arcpi.analysis import all from arcpi.management, where add field and stuff is, management import all. So that has like the add field stuff there. That's good. So the first thing I'll do is the intersection. So first I'm going to make some variables here. So bin mask for binary mask, and that's going to be equal to the zoning. So I'll just drag that there. And then the source. This source will be equal to ONS. Well, we'll call that source actually, because the source will eventually become the binary mask. But for this first stage, the source will be ONS. So we'll just call it there. We change these names later on. So now I want to intersect those two. So I'll say ZIO for zoning intersect ONS equals intersect. And then in intersect, I need to have a list in here of the feature classes I want to intersect. And that's bin mask, comma, source. Then another comma here. The output feature class, I'll call it as well, ZIO. And then join attributes, I want all attributes joined. And I'll hit enter. It cannot create ZIO. And check the environments. And the same up there. There we go. So I just changed my workspaces to Ottawa COVID geodatabase. And I'll try that again. Hopefully it will have no problem writing, and it works fine. So whenever you get that type of an error, and we saw that in the previous example as well, when it says, the reason it can't execute is because it can't create the output. it's usually an issue with where your workspaces are. So try to set them to something, to a geodatabase which is more of a base path, like C temp something, rather than a long path where it defaults under your username in a special documents folder for ArcGIS Pro, because that can be quite a long name with special characters and everything, and that can cause issues with writing. Okay, so now I'll just close off, and what we can see here, for example, just before I do close that off, if you recall here, we had in that particular census tract 17 cases, and now those have been assigned to all of the binary mask area within that census tract. And if I now look at there, it'll also have 17 cases down here, see? So we have 17 now assigned to the binary mask, wherever that happened to be. So all we did with the first intersect here was assign the case counts from the ONS neighborhood level to the finer binary mask level. So the next thing now that I want to do, now I can turn off, I can turn off zoning. I don't need that anymore. I don't need ONS on there, because now this becomes the source. So my new source layer now will be ZEO, zoning intersect with ONS neighborhoods, the ZEO layer. I'll just zoom to layer here. Here we go. So that's the new source layer to bring data from that layer into the census tracts using basic area interpolation now. So now once we've done that binary mask intersection, the whole process is just the same as it was before for simple area interpolation or basic area interpolation. So going back down here, for ZEO, the first thing I'm going to do is make the names again. So I'll say source equals ZEO. Well, ZEO is already there, so I don't need to. Source equals ZEO. And then target equals, and those are going to be the CT 2016. So I'll just drag those in, like so. Now I'll add a new field to the source to hold the original source area. So I'll say add field. That's coming again from the management toolbox, which I added at the beginning. Add field. And the in would be the source, comma, the field name. But first I have to add a field name to hold this, don't I? So I might as well do that first. Add field. That's what I just did, didn't I? So I was doing add field. Sorry about that. So add field. And then we put in the source, which is source. And then the field name that we're going to create. And this is going to be called source area. And it'll be of type double. That should pop up actually with a field type. I can then choose it. And that's it. That's good. So now if I open ZEO, again, make sure it's there. Open attribute table. Just move this. I can scroll over to the end and it should see source area there. So it's there now. Next, I'm going to have to calculate in that field the source area. So I'll use calculate geometry attributes. Calculate geometry attributes. And the features, again, will still be source. And then comma, and then in parentheses, or in brackets, and then in brackets inside of there, I have to give the name of the field, source area, comma, and then the type of property I want, which is just area. Length unit, Oops. And then for length, meters and square meters. There we go. And so this will show the same area as in the shape area field. So now I have the intersected ZO right here. And just looking at the attribute table for ZO, it has 110 features. For example, if I was to look at this, so the original neighborhood for that is Overbrook MacArthur. And you can see here there's 1, 2, and then a third one up there in terms of the polygons if I just select them all as an example. So there are 3 distinct, maybe actually 4 distinct polygons, which are part of the binary mask that were within the MacArthur Overbrook neighborhood. And they have assigned how many cases? 273 cases cumulatively. And so I have to figure out now, right, how many of those 273 cases, how many should belong to this bigger part of the polygon, to the second largest polygon, the third and the fourth. So that 273 now has to be divided up amongst these different polygons. So this now becomes my new layer and it has the source area in there already, we calculated. And so now that I have the source area here, I want to break up these polygons using the multi-part to single part tool. So going back into my Python, I'm just going to clear up that a bit. There we go. It's cleared blank slate for this part. So we want to go multi-part to single part. Multi-part to single part. Our input is ZO. And the output feature class we'll call source. And I'll just call this source here as well, because this will now be the new source of features once we divide up the stuff into the map like so. So there's source. So I'm just going to close that for a second. And let's have a look now at source. So we have source right here. So there is ZO in the background, and now there's source. So if I was to click on, I'm just going to click everything off map now, clear. That is its own polygon now. That is its own polygon. So is that one and this little one here. So now I've broken up the Overbrook MacArthur region of where people can live, the habitable region, the binary masked region, into 4 separate polygons. Right now, each polygon has 273 people showing in it. I'll make that bigger so I don't have to keep scrolling down. So you're just watching this number here. 273, little polygon, 273, big polygon, 273, second biggest 273, and the smallest 273. So obviously, we have to now figure out how to divide up those 273 people amongst these different regions. So that's all going to be done here in the source table now. That's ZO. Need to bring open the source area here. So that'll all be done here in the source area now. So now we have 1,012 polygons. We have the source area, and now we have the shape area as well, which is the current area of the broken up masked polygons. So I'm going to divide shape area by source area and multiply that by the number of cases. So I'll need to create a new field first. So I'll go back and get my Python here. So I'll add field to source. And it will be source, comma, the field name, the new field name will be called AIT. Let's call it AIT again, or small, AIT like that. type will be double, and that's good. And there it is. If I move that over here, AIT. Now I'll do a calculate field. So I'll need to first make the expression. So I want to be able to see my field names because it's case sensitive at the same time. So I'll call my EXP, I'll call it the EQN for the equation, equals, and again, single quotes. And then in the single quotes, I can manipulate the fields such as field num cases times parentheses, and in the parentheses I'll have field divided by field. So I'll put in my, not those ones. Where's the exclamation mark go? It's up there, yeah. Field divided by field. And what field will be here at the top is shape area. And the bottom field will be source area. Exact the same as binary Dasymetric mapping. So that just holds that in a string that I can then use in the calculate field expression. So I'll say calculate field. And in the end table source, the name of the field that I'm calculating is AIT. And I can even choose it from this list. And then the expression will be EQN, like so. And that's all we need to put there. And we'll see the numbers come up. There we are. So there's our AIT field. And I can look at this, for example. Right now, the sum of this field, if I look at the sum, I look at the statistics for AIT. I'll just close my Python while I'm doing that. The sum is 5,185 cumulative. And then if I go back to my original ONS, it should be very close to that, the sum of the number of cases. $5,187 versus 5,185. So there's a loss of 2 people in that process, which is fine. It's probably just due to mismatch somewhere or another. So we have a good outcome here. And right now, that source by itself could be an interesting map to look at if we wanted to look at, let's say, at the density, not the population density, but the areal density of COVID cases. So if I just click on that source and I zoom to, I'll close these tables and statistical graphs here. First, I'll make sure nothing's selected anywhere. Yeah, that's good. So nothing is selected. Then I'll click on source, go to appearance, symbology, graduated colors. And I will choose the AT field. I don't see it in here. Strange. So I'm just going to remove that source and then undo, bring it back, see if that'll undo or remove that source layer. See if it'll show up or not here in the field. There it is now. Yeah, AIT. That's just a bug, in the software. Sometimes the fields you make don't show up. So just either start a new map, add them back to the new map, or first before that, try just removing and unremoving, like I did. And I don't want for the symbols, I don't want any outline. And I'll turn off the topographic map. So that would be a aerial density of where cases are happening. And you can see from the aerial density point of view. So we have a lot in center town, downtown, and there's some areas that have, like the rural areas that have so few or pretty much zero, because they also have a low population out there too. Now, in any case, that's just to have a look at it. We're not done yet, in that we now want to use this source as the source to go and bring these to the CT level right here. So going back to my source attribute table, so again, this has 1012, and AIT is the count in each of the current ones. Now, what we need, if we're going to use this as the source for basic area interpolation back to the original, to the CT level, we need to make a source area in here, original source area, which is the shape area right now. So this source area, even though it exists, remember that's the source area of the original full parts of the mask multi-part polygons that were within each of the neighborhoods. But since this is going to be the source now, I want to recalculate source area to the current area of each of the small polygons. So for example, going back up to Overbrook MacArthur, just turn on the ONS. I'm just using that to get to Overbrook MacArthur. That's the one we were using as an example of where I'm showing you the three parts of the polygon that were in there. That's that one there. Yeah, Overbrook MacArthur. It's that region. Select it. So you can see the outline. I'll bring that underneath source. So now we can see in that outline, that was the, and maybe I'll close this for now as well so we can make it bigger. So within this neighborhood, we now have 1, 2, 3, 4 little polygons, and each one has allocated to it its share of the total number of cases that were within that neighborhood. So for example, this one has a AIT of 179. Remember, originally it was 273 for that neighborhood. 179 of those people have been allocated to this polygon right here. This one got 72 people. This one got around 4 people. And this one probably around the same. Yeah, almost the same, 3.7 people. So the 273 has now been allocated amongst these, right? So we're going to be putting this into a new geography, which is the census tract geography. And you can see, for example, the census tract, that's one right there, for example, intersects a number of different portions of things. So that census tract right there select it, intersects part of that piece, includes this whole piece, and part of that whole polygon there. So that's 77 people plus, or not 77, but a portion of 77, right? However much of that 77 is allocated to the part inside that census tract, plus this, plus however many of the 72 people are allocated to this part here. And that will then be the number of cases in that new census tract after we do the basic area interpolation. So let's make sure nothing's on, and I'll go back to analysis, and I'll bring back my Python window, and I'll recalculate source area in the source layer. So I'll say calculate field, or calculate geometry attributes. There it is. And it'll be source. And then the property here of the field will be source area. And I want area in there of the current polygons that we see here. And meters. Oh, no, I don't want yards. Meters and square meters. I think I need to have that in 2 of those, like so. So I need a list of lists. There we go. And that should be all right now. And now we see source. And I'll open up source just to make sure that everything was calculated correctly. So if I now go over here, the shape area and the source area should be the same. And they are. So there's shape area now and source area, because this is now our new source for going to the census tracts. So now I can intersect this source with the target, which will be the CTs. And let's make sure target is still the, see what it's referencing? CTs, great. So I'll say intersect, and I'll save the result. I'll call the result sit2, source intersect target 2, just so it's not confused with another variable if there's any problems with referencing. And that will be intersect. And here we'll have our features just in a single list. That'll be source and target. The name of the output feature class, I'll just call it sit2. And I want all attributes joined. And I'll hit enter. So now I'll close the source one, like so. And I'll have a look at sit2. And here in the sit2 table, you can now see there's 1,543 polygons. Because remember, we're going to have even more polygons after we intersect it with the census tracts. And we have everything we need in there. We have our source area. So there's our source area, and we have our shape area down here. So I need to create a new field in here. So I'll add field. And that'll be the sit2 that I'm adding to. The field name, I'll call it AIT. And then the type will be double. And that's all we need for that. Well, we already had an AIT in there. I'm going to redo it and call it AITF. There it is now, AITF. So now in the AITF field, I'll just calculate with an expression, and I think that EQN. So if you recall, we have EQN, which is that. So that won't work because that has num cases. We need to change that to. So I'll remake that EQN equals, and I'll just copy this and paste it here and change num cases to AIT. which is that field right here, which is again the field from that contains the correct number of cases for the binary dasymetric map. And then I'll say calculate field. I should find it there. Yep. So I'll calculate there with this equation, sit2 AITF EQN. And I'll just close this temporarily so we can have a look at it. So going over here now. So once that's done, this new AITF field, if I look at the statistics, should have the same sum as before. Yeah, so 5,184.9. So 5,184 or 185, 5,185. And again, comparing that to the original ONS. Number of cases, the total here. We're looking for 5,185. And here we get 5,187. So again, still those two people off, same as before. So everything is working good. So there's our ONS, we don't need that. We don't need the distribution anymore. That was just a quick test to see how that works. Now, our final step here is, well, right now we have the number of people in each of the, we don't need that open, just in the sit layer. So that old source. So sit is now the main layer. It looks like that. So now we want to sum the AITF values by the CTUID right here in what's called a summary table. And that will then count up the number of cases per census tract. Because right now we have a number of, like this right here, for example, all these ones together are for that census tract, 505,001.01. That's that census tract, which would be right here. If I look at the CT layer, that's that census tract right there. So the sum of these AITF values will be the sum that we want to have going for that census tract. So we need to then tell ArcGIS Pro how to, or to look at this field here, the CTUID, find the lists of unique IDs, like the first, like these four right here. And then for those four, sum up the AITF values and assign it to the label for that particular census tract, 505,001.01. And then do the same thing for this one. So there's 5 of them here. Sum up those and assign the value to 505,001.04. And then for 05, do the same thing. There's a lot more of them for 05. A lot more pieces there. There's a lot of them there. So you can see there's maybe 20 or more than 20 of them there for that one. So right there, there's 19 of them. For all those 19, sum up the AITF values and assign them to that single census tract identifier. So to start this process, I'll go over here, clear. And on my CTUID field, I can right click and say summarize. And up comes the summary statistics dialog box. The output table, sit2 statistics, or I could give it a more descriptive name like COVID by CT tests, by CTs. So the statistics fields that we want are the only one here that matters is the AITF field. And we want that summed. case field is CTUID because we right-clicked on it over here. And then I click run. I'll just now over here in the contents pane, there's my table at the very bottom, COVID by CTs. Now, if I open that up, and this is just a table, mind you, right now, I have the CTUID, frequency, which is how many of those CTUIDs there were, and that means 4 values were summed to get 171. And again, I need to right-click on that, statistics, to make sure that's 5185. And it still is 5185, so that's good. Always checking each process. Now, this table tells us how many, or it's the best approximation we have to how many cases there are in each census tract. So I'll bring my census tracts up to the top now, and I'm just going to join to the census tracts by CTUID that table. So I go to right click on there and I say joins and relates. I could add join. This will make it temporary. Let's do a permanent one. So it's not temporary, so it'll be permanently part of CT 2016. And again, CT join table will be the COVID by CTs. And then the join field CTUID, CTUID. And the field I want is some AITF. So I have CTs now with counts of COVID cases. So I might want to have a look at the counts by themselves. So I can click on the appearance for that particular thing, symbology. And I would use a graduated symbols because I'm looking at absolute counts. And I want to choose the field. Of course, the some AITF field doesn't show up here. So what I need to do is I'm going to remove it again. Remove. And I'll undo the remove so it'll show up. Like so. And so the field now, some AITF is there. Maybe I should close these so we can have a bigger look at the map. So these are the counts. Counts should never be mapped as shaded areas. So that's a no-no in choropleth mapping. Only dimensionless parameters are mapped as choropleth maps. So that means like rates, proportions, anything like that. But absolute counts, you should be using things like this, like the symbolization here. So there's those symbols, and then there's proportional symbols as well. And I'm going to put the right some AITF. And that's a proportional circle map. And you can play with the sizes here, you know. The maximum size. So we can see there's a lot, you know, downtown, center town, region, then out here, quite a few up here in Chapel Hill. If you were there, and of course if we just look out here in the suburbs and even the rural areas, some are pretty big there too. So that's just visualizing the data as counts with a proportional circle. If we want to look at, let's say, the density, we could do it by population. So I could say instead, I'm going to go back to now a graduated colors map, and I'm going to choose the some AITF, and that's going to be divided by the population, 2016. And so that's all right as a proportional, or I should say as a shaded polygon map or choropleth map, because we're now looking at something that's been normalized. Interesting how we see it much, the East Ottawa seems to have much higher rates than kind of the western part of Ottawa. So that's interesting. I could open the table and I could do some graphs, or I could do some graphs right here. Right click on the layer, and then I want to go create chart. And I want to create a scatter plot to examine the relationship between, let's say, visible minority and some AITF, but we can't. And so what we see here, just in terms of numbers, right? So as the visible minority, well, that's visible minority, as visible minority increases, there's a corresponding increase in the total number of COVID cases in Ottawa. So that's what that line shows there. And I can just change that to different variables to look at them. How about income? There's what we expect for income. As income increases, the number of cases decreases. And if we want to look at Aboriginal, again, same thing as with visible minorities. Increasing Aboriginal numbers mean higher numbers of COVID cases. How about with the university education? I'd hypothesize it will be negative. So more university, less COVID. Interesting. It's actually, this would suggest more university, perhaps more COVID. That's something I didn't expect. Public transit and COVID, that should be interesting. Positive. Often because this could just be a confounding variable or something that's collinear, but certainly, there's some positive relationship there between the use of public transit and within a region, so people using public transit to get to work from where they live, and COVID case increases in Ottawa. Look at that. Public immigrant, again positive. These relationships don't look too bad at all in terms of what we would expect. Non-immigrant, also positive though. So perhaps there is no immigrant effect. Certainly visible minorities. Income. Aboriginal status, like so. So that's with raw count data, obviously. So the other thing we could do is we could go in the here, add various fields to do normalized stuff. So we look at rates, Aboriginal status is a rate of the total population versus the COVID rate. So I could go back to my Python, for example, here, and I'll say add field. And this will be going to sit CT 2016. Let's just see if that's called target still. Yeah. So I'll say add field to target. Field name, I'll just call it Covert. The type, double. So I'm calculating in there, such. So I'll make it COVID rate. And this is again with 2016 data. It's not a big deal. 2016, 2019. Although I should have brought over the 2019 estimated data instead, but I didn't. So in there, I'll calculate the COVID rate. So I'll say calculate field. Well, first I'll make an EQN, an expression, in single quotes, and it's going to be field divided by field. I need to see those field names to do that, so I'll bring that up here. So we're going to have at the bottom pop 2016, and at the top we will have the sum AITF field. And then we'll multiply that whole thing by 100,000 to get the rate per 100,000. Otherwise, the numbers are super small. Then I'll say calculate field now that I have the expression. And in here, it will be target. The field, Cov RT. And then the expression, EQN. So now I have a COVID rate. So there's the rate of COVID per census tract times 100,000 people. So that means 534 in 100,000 people, etc. And then I'll do a rate of, let's say, the ones that showed positive Aboriginal status, immigrant status, visible minority, VisMin. So I'll do an add field again. Target VisMin RT for rate, and it'll be type double. Then I'll calculate field and make an equation again. I'll just go up and use the same equation as before. And that's going to be VisMin divided by population times 100,000. And then all I have to do is that. I have to go back and I'll use calculate field again. And I will have VisMin RT. And the equation. So now we have two fields, the visible minority field as a rate per 250,000, per 100,000, I should say, and the COVID is a rate of, or per 100,000. So I'll just double check. I'll make a, see how the rates, how it looks as rates. So I'll say create chart, scatter plot. Again, I'll put on the bottom the, oh, of course they don't show up, so it's nice and buggy. So what I'll do is I'm going to remove that again and re-add it by undoing the remove process. And I'll go back to charts, scatter plot, x-axis will be the visible minority rates and the rate of COVID on the y-axis. Well, it actually looks not too bad as a relationship. And we see that again, that positive relationship that we saw with the raw counts. So this is the type of analysis now I can do, or I can approximate, because now I have my COVID data at the scale of the census tracts where all of the census information is collected. And that's just one example of using binary dasymetric mapping, because it provides a more accurate way to change geographies, because you're bringing the variables of interest to the smallest possible spatial scale before they're reallocated to another geographic zoning. So in our case here, we went from Ottawa neighborhoods to binary dasymetric map. And then for the binary dasymetric map, we use that as a source to redistribute or aerially interpolate the values to the census tracts.